Right, welcome back to our second stats lesson. I hope you enjoyed the first one. I know the calculation could be tedious, but they do give us some useful information, okay? We are going to be looking at probability today, actually. And we're going to be looking at probability involving the binomial distribution, okay? So this binomial distribution basically is what we're looking at today, okay? But first, let's look at probability distribution. It is a complete listing of all possible outcomes of an experiment with their associated probabilities. A probability distribution can be displayed as a list, in a table, in the form of a graph such as histogram, or by a formula. The sum, okay, this is key, the sum of all the probabilities is 1. That makes sense, right? If you include all the possibilities, the probability will be 100%, right? So that's why the sum of probabilities is 1, okay? All the possibility. There's no way it's more than 1 or less than 1. Okay? So it's always the sum of all the probabilities would be 1. Okay? So let's look at, here's an example. Let's look at it, I guess. We have a green die and a blue die, and they are rolled, okay? The outcomes are shown in the table below. So it doesn't matter. Let's say this is the green die and this is the blue. Okay? Green die. Okay, so you can see if you roll 1 for the green and 1 for the blue, you get a result of 1, 1. If you roll a 2 for the green, 1 for the blue, then you get 1, 2, and so on. Okay, so this would be the total possibility, right? 1, 1, 1, 2, 1, 3, 1, 4, all the way to 6, 1, 6, 2, 6, 5, 6, 6. Okay, so this is the total possibilities. There's no other a regular die, obviously, regular 6-sided die, okay? Obviously, it could be other sizes, but let's say a regular die, okay? So these would be the total possibilities, okay? Part A says, use the table to complete the probability distribution for the variable s. I don't know what happened. There's a weird space here, but that's okay. I don't think it happens on your handout. So sum, on the left column, these are the total possible sums that we can actually get, right? 2 came from 1 plus 1, right? That's the sum between those, or that's the sum of these two dies, okay? Or die is the plural already, okay? Oh no, is die the plural or dice the plural? I don't know. I think dice is the plural. No, is it? Okay, who cares? Okay, sorry, English people, they care, okay? Sum of 2 came from 1 and 1, okay? So the probability is 1 out of, well, how many possibilities are there? Well, there are 36 of them, right? Makes sense, 6 times 6, or you can see there are 36 boxes here, okay? So 1 out of 36. The sum of 3 came from 1, 2, 2, 1, so that's 3 out of 36. The 4 came from 1, 3, 2, 2, 3, 1. So there are 3 of them. Oh my goodness, I cannot count. For 3, it's 2 out of 36. This is 3 out of 36. I think you see the pattern, right? It's just the diagonal line. And this will be 1, 4, 2, 3, 3, 2, 4, 1. So there are 4 of them. For the 6, it's 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. That's 5 of them. For the 7, 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. So that's 6 of them. And that's 5 of them here. 1, 2, 3, 4, 5. And then 4, 3, 2, and finally 1 out of 36. Okay, so this is the probability distribution, basically, expressed in a table. Okay. Part B, we want to display this probability distribution in a histogram. So if you recall what a histogram is, we are going to draw a histogram, okay? So to draw the histogram, we must label the axes. For the x-axis, in this case, is the sum. And for the y-axis would be the probability. So I guess it's probably better if we convert. you know what? Who cares? It doesn't matter. Okay. What we're gonna do is here's 0, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 2, 1, 1 to 2, 11 to 12, 0 to 1. Okay, so I think you see I run into a problem here. 12 is not quite there, or this grid is not quite big enough. So I'm gonna actually start from 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so, and then the probability, do I have enough boxes? Okay, so I'm gonna say each 2 boxes is 1 out of 36. So that'll be 2 out of 36, 3 out of 36, 4 out of 36, 5 out of 36, and that's 6 out of 36. So for the first, I guess, column, if you will, that's 0, well, that's 0 to 2, right? Not including 2. Okay, not including 2. So 0 to 1.999 basically. The second column would be 2 to 3. We do have a possibility of having 2, but again, this is not quite 2 to 3. It's 2 to 2.999. So my first bar, or my first bar will be here, 2 to 3, and then it will be at from 3 to 3.999. It happened 2 out of 36 times. And then 4 to 4.999 happened 3 out of 36 times. Notice how bars are all connected. From 5 to 5.999, it happens 4 out of 36 times. And then keeps going, 5 out of 36. Okay, I'm going to pause the video. I think you see how this is going here. Okay, so once you complete this, you get this beautiful symmetrical graph, right? So again, the last piece here actually goes from 12 to 12.999, and really it's the 12 that we are looking at, not really anything more than 12. But anyways, that's what our histogram would look like. Okay, part C, it says what is the sum equal to 6? What's the probability? So this P represents probability. What's the probability that the sum is more equal to 6? We have from our data here, if it's equal to 6, it's 5 out of 36. That's the probability. What's for part D? What's the probability that the sum is smaller than 6? Notice it does not include 6. So we're looking at 2, 3, 4, and 5. So if you add those up, that's 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. So the probability that the sum is less than 6 is 10 out of 36. Finally, what's the probability that is greater than or equal to 9? So then we take 9 and add, the probability that the sum is 10, 11, 12. So that's 4, 3, 2, 1. Again, that is 10 out of 36. Okay, now if there's an F, and I ask you, what is the probability, what is the probability that the sum is less than 9? In this case, I think it's clear. We don't actually need to count from 2 to 9. What we can do is we take a look at this statement and that statement. They basically will include everything, right? So if bigger than or equal to 9 is 10 out of 36, that means less than 9 would be 1 minus 10 out of 36, right? The total, which is 1, take away, that's more than 9, more equal or equal to 9. So this is 26 out of 36. This is what we call the complement, okay? So these two are a complement of each other, right? Because they add up to 100%. Okay, more than or equal to 9 is a complement to less than 9. So to find the probability, we can just take away the probability that is more than or equal to 9 away from 1. Okay, so 1 minus 10 out of 36. Okay, so that's the probability distribution, basic concept of it. We are going to be talking about binomial distribution. That's what we're going to what we mentioned earlier. Binomial distribution is a special case. Okay, it is a distribution of all possible outcomes and their related probabilities from a binomial experiment. And what is a binomial experiment? Well, it is an experiment with only two possible outcomes. So either you fail or you succeed. Okay, fail, succeed, fail, succeed. Okay, or fail or success. Okay. The binomial distribution can be applied in probability situations using the formula right here. Now, that's the probability of X happening, okay, event X. N is the total number, okay. X is the number of favorable outcomes, or N would be the number of trials, I guess, how many times we do it, and X the number of favorable outcomes. Okay, P is the probability of happening, Q is the probability of not happening. Okay, and this C here, okay, so this NCX, this is a button on your calculator. Okay, so really, if you learn about permutation or combination, if you actually learn the probability units, then you'll see this button. Unfortunately, this is taken out of the pre-calc stream of math, so you won't see this anymore in pre-calculus, but it is definitely on your calculator. If you look for it, there's an NCR button. Okay, on the calculator it says NCR. Again, N is the total number of trials, and R is the number of favorable outcomes that we want. Okay, Q, so P is the probability of happening, Q is the probability of not happening. Okay, again, I think it's easier if I just show you an example. Okay, so here is the example. 5 dice are tossed. What is the probability of rolling? A, exactly 3 twos. Okay, so we are interested in twos. Okay, so P would be, what is the probability of rolling a 2? So P would be 1 out of 6, right? The probability of getting a 2, so success, is 1 out of 6. That means the probability of not getting a 2 is 5 out of 6, right? That's the probability of failure. Okay, you fail to get a 2, so 5 out of 6. Okay, so the probability of 3 twos is going to be N. So N is the number of trials, right? So we tossed 5 times. or X is how many times we want the 2. So we want 3 times, right? We want exactly 3 twos. The probability of getting a 2 is 1 out of 6. And the exponent is, well, because we want it happen 3 times, so it's 3. The probability of not happening is 5 out of 6. And this is N minus X, so 5 minus 3, right? So basically it makes sense, right? This 1 out of 6 cube, this means this happened 3 times. We want to have a 2 3 times, and we want to not have a 2. So 5 out of 6, the chance of that happening is 5 out of 6. We want that happen twice. The phi C3 means it. Okay, so what that means, that represents different ways of arranging success and failure, because it could be 2 2 2 and not a 2, not a 2, right? Or it could be 2 not a 2 2 2 not a 2 not a 2. So this phi C3 tells us how many different ways we can arrange these. If wait a minute, this is too many. 6 times. I'm gonna erase that 2 right there. Okay, so that's 5 times. Phi C3 represent how many ways we can arrange these. Okay, I don't know what I'm talking about. This is okay. Should be like that then. She's doing things on the fly. Okay, so then again, it represents how many times, how many different ways we can arrange these scenarios, I guess. Okay, so that's what this formula represents. It makes sense, actually, total sense. Okay, so if you put this into calculator, phi C3, if you put that into calculator, you should get 10. Okay, so that's 10, and this is 1 out of I think it's 216. and then 125 out of 216. Okay, so you just put this into a calculator. You should be able to get, so that's 1250 divided by 216 times 216. Okay, you should get 0.027. Okay, so 2.7% of getting exactly 3 2s. Okay, so that's part A. Part B says, what about at least 3 2s? So at least 3 2s means we can, this means either 3 2s or 4 2s or 5 2s. Okay, so the way to calculate this would then be 3 2s, at least 3 2s, I'll write it down, 3 2s would be 5, so this would be the probability of 3 2s, so we just did, right? That's this formula right here. 5 minus 3 is 2, so I'm just going to write that. Anytime you see or in probability means you are going to add them. Okay, so 5C4 in this case, because we have 5 trials, we want 4 2s, so we want 4 of them. 1 out of 6, we want this happen 4 times. We want 5 out of 6 happen once. Plus 5C5, 1 out of 6 to the power of 5. And we don't want 5 out of 6 to happen at all, so that's to the power of 0. Remember, anything to the power of 0 is 1, so we don't need to write, you know what, I'm going to write it out. 5 out of 6 to the power of 0. Okay, and now just put this into a calculator and add them up, and you would get your answer. So I'm gonna do it and see what we get here. 5C4. I'll pause the video. You can do it on your own and then see if we have the same answer. Okay, so I got 0.03. Okay, so 3% chance. So you can see it's not likely that you get, 3 2s is already quite unlikely, but 4 2s and 5 2s, that's very highly unlikely. So you can see it actually doesn't increase by a whole lot, okay, from 0.027 to 0.03. Okay, it doesn't change a whole lot. Okay, all right, last example. It says 30% of patients taking a certain migraine drug, well, migraine is horrible, by the way, suffer side effects. If the drug is given to 8 patients, what is the probability that at most 2 suffer side effects? So at most 2 means 0 patient suffer side effects, or 1 patient suffer side effects, or 2, right? At most 2. This at most 2 means 0 patient or 1 patient or 2 patients. So the probability of at most 2 would be, basically we add up these 3 probabilities, right? So again, the formula is NCX p to the power of x times q to the power of n minus x. Okay, so in this case, it's going to be, we have 8 patients. We don't want anybody to have side effects. The probability of having side effects is 0.3, right, 30%, to the power of 0 times. And not having side effects is 70%, and we want this happen 8 times. Okay, does that make sense? Plus 8C1, 0.3 to the power of 1, 0.7 to the power of 7, right? We want 1 patient to have side effects, so 0.3 to the power of 1. If 1 patient have side effects, that means 7 does, they don't. So 0.7 times, to the power of 7. Continue, it will be AC2, 0.3 squared, 0.7 to the power of 6. Okay, so 2 people with side effects, 6 people without side effects. Put this into a calculator, you should be able to get your answer. Again, I'm going to pause the video, you can calculate and see if we get the same value. Okay, so once I put this into calculator, I believe I get 0.552. Okay, so 55.2%. That at most two people will suffer side effects. Okay, so we are looking at probability in this lesson. I think again it's very useful. You can see it gives you a lot of different kind of applications that we can actually do in real life. Okay, so like I said, I think stats is very useful. Probability, part of the stats, part math, I guess. In UBC there are actually two courses that are same course basically, but two different course title. One is stats and one is math, under math. Okay, so probability, it really is kind of both. I think it's quite fun. I hope again you enjoyed it. Good luck with your homework questions. Bye.